Edexcel Core Pure, Calculus 6, volumes of revolution and mean of the function, rotation about the y-axis for parametric curves. We've seen how we can find volumes of revolution in previous videos. And now we're going to look at the case where we do a rotation, a complete rotation about the y-axis. So in the previous video we looked at a rotation about the x-axis and the formula is given, but this time we're going to spin the curve all the way around the y-axis using this formula. Notice the interchange of y with x, and the limits are now y coordinates, so we're going from C up to D. Now we're going to look at finding this formula of revolution using a parametric form. Now the parametric form is in the A-level specification, which you may not have done yet. If you prefer to come back and watch this video at a later stage, then that would be fine. But we're now going to look at how t, the parameter t, has control of the value of x and the value of y, where x equals cos t and y equals 2t. Notice the restriction on t is there's a restriction from 0 to pi by 2. So this curve is now going to spin around the y-axis to produce a solid of revolution, and we're going to find the volume created. So we know the parametric equations are x equals cos t and y equals 2t. We know that it's spinning around the y-axis, and we're going from y equals 0 to y equals pi to look for this volume. So quoting the formula for a volume around the y-axis, the volume is the integral of pi x squared dy, and in this case we're going from y equals 0 to y equals pi. We need to substitute for x, but also we need to note that y equals 2t. So dy by dt is 2 and dy is 2 dt. Don't forget to consider your limits as well. So when y is 0 we need to think about t, and y is pi we need to think about t. So if y is 2t, when y is 0, t is nothing, and when y is pi, t is pi by 2. So when we use the parametric forms and make our substitution, we will end up with a top limit of t is pi by 2 and a bottom limit of t is 0. I'm going to bring pi out of this integral, and we'll have x squared, which is cos squared t, times dy, which is 2 dt. We've seen the problem previously of integrating cos t squared and the fact that we need to use an appropriate trigonometric identity. So I'm going to bring the 2 outside this integral as well, so it's 2 pi, the integral from 0 to pi by 2, and cos squared t is a half of cos 2t plus 1 dt. The 2's will now cancel and I'm left with pi, and I'm ready to do the integration. Integrate cos 2t becomes sine 2t, but it will need balancing up with a half. Integrate 1 is t, and now we're ready to sub the limits in. So subbing in the top limit is a half sine double pi by 2 is pi, plus pi by 2 minus pi times subbing the bottom limit is clearly 0. Sine of pi is nothing, so we are left with pi times pi over 2. The volume is exactly pi squared by 2. Don't forget to do integrations like this in radians. Because we're dealing with trigonometry, we need to be working with radians. So there is a complete method, and again we've substituted for x squared, and you can think of dy as being dy by dt times dt, if that helps you with the switch to the parameter. How do we integrate cos squared t? We need to use that double angle identity, and that will allow us to get to the exact volume. In the next session we're going to be looking at the mean of a function.